Hello, Brisbane. How are you all doing? Earlier this year, I bought a book. I went onto amazon.co.uk and I decided I wanted to buy a guidebook to London. Now, I've only lived in London for the last 20 years. I thought maybe I'm missing something good. So I went on there, I looked up a bunch of books, and I sort of scrolled down and I found this. The Essential London Travel Guide 2023 by Nash a Day. And then, looked pretty good value, £11.91 overnight shipping. And looked like it had pretty good reviews, 62 ratings, and most of them positive. And so I clicked Add to Basket, and I ordered it. And it arrived the next morning in one of those little brown cardboard Amazon envelopes. Now, I'd like to read you a little excerpt from Nash a Day's Travel Guide to London. Discover Westminster's hidden treasures. Embark upon a journey to discover the picturesque promenades, tranquil bodies of water, and avian inhabitants of the verdant and extensive estate of Hyde Park. Observe the ceremonial rotation of centuries at Buckingham Palace, the esteemed abode and governmental centre of the reigning monarch. This event shall commence at precisely 10:45 a.m., ensuring timely arrival to secure optimal viewing opportunities. The estimated duration for the task at hand is approximately 2,700 seconds. It is advisable to peruse the website prior to attendance, as the frequency of guard changes typically amounts to a bi-weekly occurrence. So there we go. So we don't want to miss that, right? Now, the thing that the book is talking about here is this. This is called the changing of the guard. It happens a couple of times a week. It does start at, it does last approximately 2,700 seconds. It doesn't start at 11 o'clock, 10:45. It starts at 11 o'clock. It has been going since 1656, and in all that time, nobody has ever referred to it as the ceremonial rotation of centuries. That is not a way human beings talk about the thing that happens. Now, I am going to go out on something of a limb here, because Nash a Day, the author of my London travel guide, Nash has had a really productive year. Like, since January, Nash has written the Guide to London, the Guide to Paris, 2 different guides to Rome, another guide to Paris, a book about a guy's journey through life, the Woman's Guide to Slim and Confident Weight Loss, another travel guide to Paris, a short-term rental wealth strategy for getting rich with Airbnb. Nash is cranking out the literature. Now, I'm just going to go out on a limb here. Nash, if you're out there, I'd like you to click all the pictures of the bus. Because I do not believe that this book was written by a human being. I'm sure that some kind of humanity was involved, but I think that pretty much every word in this book came out of some sort of generative AI or some kind of language model. Now, I just want to kind of disclaim a little bit here about terminology and stuff. There is a lot of stuff going on at the moment about AI, this umbrella term that covers everything from having quite a clever database to trying to simulate neural networks on quantum computers in the cloud. I am not an expert on this kind of stuff. There are people here who are. I've been to some of their talks. It's really interesting stuff. Absolutely take the time to understand the nuance and the technology and the complexity. What I'm interested in is kind of geeking out on the boundary between technology and society. How does technology affect the way that normal people do their jobs and live their lives? And how do normal people doing their jobs and living their lives impact the way that we design and build and deploy and maintain the systems that all of us work on? So we're not going to get too hung up on the specifics. Some people say, oh yes, artificial intelligence is real. Some people say it is neither artificial nor intelligent. We're not going to worry about the distinction too much. Now, to me, this year and this book feels like what I call a tipping point. Now, if any of you all have been out and ridden roller coasters, you'll know that when you're riding a roller coaster, you know something is about to happen, because you can see yourself climbing up to the top of the hill at the beginning of the track. And you know that when you go over the top there, everything is going to go a little bit crazy for a little while. And the first time that you ride a roller coaster, you get to this point around about here, and your brain looks over the edge and goes, yep, we are going to die. There's no way this is a survival. I see ya, I'm out of here. And you kind of like black out for a couple of seconds, and then you come out the bottom and you're like, wow, that was cool, I want to do that again. Now, it feels a little bit with AI and machine learning at the moment like we are just going over the top of that roller coaster and it's all going a little bit crazy and we don't know what's going to happen next. But when you've been around doing stuff with tech for as long as I have, You've seen these kind of tipping points before. And what I want to do today is I want to look at some examples, some case studies from my own career within the duration of time I've been working with tech, and see, is there anything that we can learn from those that might help us make sense of what it is that's happening at the moment. And we're going to start here. Does anybody know what this is? Yes, it's a chromatograph CP341. You don't get points for that. This is a scanner. Does anybody know what a scanner is? Back in the day, when photography was done using chemicals and lenses and optics and computers were not involved, if you needed to get a photograph into your computer for whatever reason, you would use one of these. This thing cost about $1 million US. And there would be one of these in newspaper offices and press bureaus. Scanning and turning photographs into digital bits was a big deal. It was a very expensive, skilled, time-consuming process. Now, if you plot a graph of camera sales over the last sort of 70 years, film cameras, analog cameras that work with emulsion and chemical development, all this kind of stuff, they hit a peak around the year 2000, about 40 million units sold that year. Then digital cameras, they do this. There is this massive spike, about 120 million digital cameras a year, and then that spike falls off a cliff because smartphones. Why is people going to go out and buy cameras when everyone has a camera in their pocket already that is probably better than the one you spent all your money on 10 years ago? Now, this is a good graph. It's interesting. It's accurate. There is a story hidden in this graph. It's the story that happens at that point there, and it's a story about the Olympic Games. Now, I love the Olympics as a sort of watermark of media technology because it happens every 4 years, and 4 years in tech is short enough that it makes sense to compare this one to the last one, but it's long enough that there is time between these installments for significant innovation. Now, if you were sent on assignment to cover the Olympic Games in Atlanta, Georgia, USA, 1996, as a photographer, you'd take a film camera, because that's what you had. You'd take a couple of film cameras, a bunch of good zoom lenses and everything. You'd spend your whole day taking pictures. And at the end of the day, once all the events had wrapped, you would go to the Kodak press desk in the Olympic Village, and you would give them all your film. They would develop it, turn it around inside an hour. You go back to your hotel, and you'd look through all of those negatives. You'd pick out the good ones, and you'd put them in an envelope, and you would overnight FedEx them to your newspaper office. They would make up the next day's back page. Now, the 2000 Olympic Games was different for a whole bunch of reasons. You'll know where 2000 was held, right? Sydney, Australia. Now, there were three things that made the year 2000 Olympics dramatically different in terms of photography. One, now this is a success story about Australian internet, and you don't get a whole lot of those, but by the year in 1996, if you were doing email from your hotel room, you were a nerd. You had a laptop with a modem, and you'd plug it into the phone line, and you'd dial up, and you'd have international roaming. Most people didn't do that, and if you did, you were lucky to get 28.8 or 33.6 kilobits per second. By 2000, hotels had business centers with ISDN, with digital lines. So you'd pay a premium for it, but you could get reasonable internet connection in hotels all over the world, including Sydney, Australia. The second factor was the time and the distance. Lots of the folks who went to the Sydney Olympics, they were shooting on digital. And they were sending their pictures back to the press office, and they were realizing fairly early on that they were still shooting on film as well. But they were taking digital photographs, they were sending them back, realizing that those pictures were getting used because the time and distance meant overnight FedEx from Sydney to New York. That's not really a thing. And once you factor in the time difference, by the time the Olympics is wrapped, you've already missed the overnight press deadlines for something like the New York Times or the Washington Post. And the third factor was a device. Is this one, the Nikon D1. Now, this was the first digital camera that was built as a professional tool for professional photographers. This was not amazing. This was about 1.4 megapixels and had a bunch of features. It didn't really have kind of burst photography, so you had to line up your shots and time them quite quickly. The pictures that it took were not amazing pictures compared to what people were used to seeing on film, but they were there. They were ready, they were available. You'd go back to your hotel room, you'd send a couple of pictures off, then you'd go back and look through all the hand lenses and get ready to send the FedEx. And they realized, the photographers working the event realized within a couple of days, no one was printing the film pictures. They were all printing digital because of the convenience. Now this meant there was this tipping point because people started pouring investment into digital photography because it had just gone mainstream. It had caught the imagination of the public. The media was like, this is good enough. This is one of the pictures that was taken and run on the back page of a newspaper, taken at the Olympic Games on the Nikon D1. Now, the D1 it didn't come out of nowhere. It was a product of like 3-4 decades of innovation going back. This is the first digital camera created by Kodak in 1974. It's got a tape deck on the side. You can see the little cassette where it stores your photographs. But the D1 was the tipping point. It was the moment when we went over the top of the roller coaster and everything changed. 4 years later, the Olympic Games in Athens, Greece, everybody was shooting on digital, on cameras that were, unbelievably superior to the Nikon D1 of only 4 years earlier. Fast forward to today, we have things like this. This is the Canon EOS M200. This is a mirrorless SLR camera. This thing is phenomenal. It's got about 24 megapixels of resolution. It'll shoot high-definition 4K video at 60 frames per second. This thing is so cheap that I bought one of them to use as a webcam. That's the level of kind of commoditization that we've seen with digital photography. Now, if you had gone into the Kodak Press Center at the 2000 Olympic Games, in 2000, Kodak was an industrial powerhouse. They had something like $1.6 billion in cash. They had their own skyscraper, the Kodak Tower in Rochester, New York. If you'd gone in and said, you know that Kodak is going to stop making film by the end of this decade, they'd have been like, don't be ridiculous, that's not going to happen. If you'd said to them, oh yeah, and 2 years after that, Kodak is going to file for bankruptcy, they'd probably have thrown you out for trying to start a fight, But the hidden story, the thing that's in all of this, Kodak did not become a, multi-billion-dollar company because of photography. Kodak sold chemicals. Kodak sold chemicals and the machinery used to develop photographs. Now, if you were shooting photographs on film and getting them developed, you'd probably pay, I don't know, about $5, pounds, whatever. You'd pay that much for a 24 exposure reel of film, and about the same to get it developed. Quick back-of-the-envelope calculation, Kodak probably made around 10 American cents for every photograph taken on this planet until the year 2000. That's a lot of money. And so when digital came along, it isn't that people stopped taking photographs. We didn't want to stop sharing photographs. We still wanted to take pictures, share pictures, look at pictures, but the chemical industry that underpinned that had been undermined. That's the revolution that happened there. Kodak still exists today. Wikipedia says they produce products related to their historical basis in analog photography, which is like, oh, look, nostalgia company, isn't that nice? But they're not dead yet, as we're going to see in a minute. Now, around the same time that all this was going on, there was another revolution happening, another tipping point about converting the real world into bits and bytes. And this one starts a little earlier. Starts around 1991 with a thing called the MPEG Layer 3 audio codec. Now, MP3 is older than people think, but for the first sort of 5-6 years of its life, MP3 was not terribly exciting because there were no computers in the world that were fast enough to play it. You could get an MP3 file, but if you wanted to listen to a 4-minute pop song, you'd have to wait 10 minutes for it to decompress before you'd have audio you could actually play. And then you'd have to delete it to get back that space on your 40 megabyte hard drive, and then you'd have to choose another song and decompress that one. This was not a great consumer technology. Then you fast forward to the Pentium 60 processor, around about 1996, 97, and suddenly you had computers that could actually play MP3 audio files, which was great if you were the kind of person who listened to all your music in a room that had a computer in it, which is basically nerds and college students. The rest of the world is like, well, I listen to music in my car. I listen to music on the train. I listen to music in my living room. I play music in my restaurant. None of these people were interested in MP3 as a format. It didn't solve any problem they had. The tipping point was this device, the iPod, October 2001. The thing that made an entire generation of normal people go, I want the nerd thing. I don't care that it's a nerd thing. It's really cool. I want it. Give me that. I want to be able to listen to music. Now, the iPod was not in and of itself a revolutionary device because it didn't really change the way people listened to music. This device was at the heart of an ecosystem that was about how people bought music. Because MP3 existed, the hardware existed, all the pieces were already there. It took Steve Jobs to sit the record companies down, get them to stop panicking for a couple of minutes and say, look, this is an opportunity. What you have here, at the moment, you all sell plastic. I know you think you're in the music business. You're not. You're in the plastic business. You sell plastic CDs in plastic boxes and plastic records and plastic tapes and plastic films in trucks, and you have these vast pressing plants full of industrial chemicals, and you have to have retail stores with cardboard boxes full of inventory. What if we could get rid of the plastic? What if you could sell a song, just the song, for 99 cents? And we'll take 30% and you can keep the rest. And so downloads and then eventually streaming was born. And again, this revolutionized what it meant to work within that industry, because it took away a dependency on a sort of industrial process as a way of delivering the thing people actually wanted. Because people didn't really want the plastic, they wanted the music. There's a couple of folks out there who love vinyl records. We're still here, we still buy vinyl records, but the vast majority of people, they just wanted to listen to songs. And they didn't really care very much about where it came from. Now, the key thing that has changed in both of these case studies is something that used to be expensive. And when I say expensive, I'm talking about it exercises a constrained resource. That might have been time, that might have been money, natural resources, bandwidth, something that you didn't have an infinite amount of. And so you had to make careful decisions. When you had 24 exposures on your 35mm color film, you chose what photographs you were going to take. And then 2 weeks later, you got to look at them and see whether they were any good or not. When you could, your allowance was enough that you could buy one new album every month, you chose really carefully what music you were going to invest in and what you were going to listen to. And with the advent of digital photography and digital media, what it did is it started bringing that cost down towards zero. Now, I was at an event in Utrecht in the Netherlands earlier this year. One of the other speakers there was this guy. This is David Foster, and he founded a company in London called Applied Data Science Limited, which is doing some kind of really interesting, it's like consultancy on how companies can incorporate data science and machine learning into their own strategies, whether it's worth them training their own models. And he had this slide, which had this quote on it that I thought was really interesting, really struck me. He said, generative AI reduces the cost of human-like thought to near zero. Now, we're going to do a little experiment now. What I'd like you to do is, everyone here, I want you to think of a purple penguin. How much did that cost? Maybe if you've had a traumatic experience with a purple penguin, there's an emotional cost here. But financially, thought is cheap. We think about stuff all the time, but thought is also, in and of itself, it's not really worth anything. When there's, like a natural disaster, like an earthquake, and you see all the B-list celebrities tweeting thoughts and prayers, you think those thoughts have any value to the people who just lost their homes? Or someone is on a train. They're looking out of a window, they see somebody on the station platform kind of, clutch their chest and stagger a little bit. They think, wow, I think that person might have had a heart attack. Now, if they pick up the phone, call the paramedics, yeah, that's part of a useful, a valuable process. If they just think it and get on with their day, let's imagine we built a machine to do that. We wired in all the surveillance footage from all the cameras and all the railway stations and fed it into a neural network that just sat there looking for heart attacks, but then it didn't tell anyone what had happened. Like, we've invented sociopathy as a service. Well done. Awesome stuff. Now, the current generation of generative AI, the thing that has kind of made it interesting is that it can take it one step further. Thought has no value until thought is followed by action. And DALL-E 3, Midjourney, ChatGPT, Google Bard, all of these things, what they can do is they can emulate this kind of thought process, but then they can put out results on a screen, or they can get them to come out of your speakers. And this is kind of an interesting boundary point for me, because the output of all of these systems so far is restricted to things which are digital, things that we can consume as pictures, pixels, video, sound, audio, text, all these kinds of things. But we haven't yet hit that kind of tipping point into reality. Now, the last couple of years, we've all lived through this very kind of, historically interesting, but it wasn't a whole lot of fun actually living through it. And lots of things we took for granted were taken off the table. You couldn't go out. You couldn't go to an event like this. You couldn't go to a restaurant. They were all closed. You couldn't get on an airplane, go and visit your friends. And so we figured out how to do stuff online. We reduced our industry, our collaboration, our experience to something happening in front of you on a screen. I have done hundreds of hours of online training and online conferences and online pub quizzes. And, there are benefits to these kinds of online digital events. They are inclusive. They are accessible. They allow people to participate without having to travel, so they have a lower ecological cost. But they kind of suck. Because there is something fundamentally meaningful about being in the same room as other people and the kind of conversations that have while you're all queuing for coffee together after you've just watched a session. And I think that the real world will always deliver more meaningful experiences in terms of human interaction and collaboration than we figured out how to deliver digitally. Now let's go back to talking about books for a second. Because the thing about my London reference guide that kind of really surprised me, it isn't that a machine wrote a book, it's that a machine wrote a book, an actual physical book. Because I have grown up in a world, as I'm sure many of you have, where we've been taught to trust books, because books have editors, and books have copy checkers, and books have proofreaders, and books have publishing houses that want to make sure that they don't print mistakes. Whereas the web, yeah, whatever, just stick it up. If anyone reports a mistake, we'll fix it tomorrow. You know, the models like the Wikipedia collaborative thing. Wikipedia is eventually consistent, but at any given time, there's a vast number of mistakes on there that just no one has found yet. And they will, and they'll get fixed. But we've kind of grown up to rely on books, to treat them as authoritative in a way that online media isn't. And so when a machine can make a book, I don't know what to make of it. Like, it's got to be right, it's a book. But then you open it up and you're like, this is like the worst web page ever, only it's been printed out and put in covers. Now, the difficult thing here, I bought this book from Amazon. And Amazon is one of the most successful companies in the world in terms of their market cap, the number of industries they've gone into, the number of services they provide, and the amount of money that they make out of doing it all. Now, I don't know how many human beings were involved in creating and getting this book to me. I don't know whether Nash a Day exists. I don't know who's feeding the prompts in. I don't know. I know that a machine took the payment because that was my computer. I know that a machine did the fulfillment. I know that this was print on demand because you can tell from the quality of the binding. I know a human being brought it to my door because I saw them and I wished them good morning and thanked them for bringing it. Now, there may have been a person whose job title was "Don't sell shit books." That person has been eliminated because that does not scale. If you want to become a trillion-dollar corporation, you need to eliminate all the things that don't scale. And human beings don't scale at all because we are messy and we are made of meat and we complain and we need bathrooms and we want to eat lunch and sleep and we want, all these breaks and workers' unions and all these kinds of things that don't scale. And so we start approaching some kind of seriously dystopian Skynet territory here. But there is an angle in all of this that I had never thought about until earlier this year, and perhaps some of you had never thought about it until right now. The London Travel Guide is not the only book available on Amazon right now. Now, in my London Travel Guide, it's mostly pretty accurate. The writing is weird, but most things it kind of gets right. But once in a while, it makes a mistake. Like, it recommends a restaurant called Sushi Samba, which is situated in the iconic Heron Tower in Covent Garden. Now, this is London. Heron Tower's over here. It's the Salesforce building, if anyone knows that one. Covent Garden is over there. That's about 4 kilometers apart. Heron Tower ain't in Covent Garden. If you go there looking for sushi, you are going to have a bad time. Now, okay, big deal. Yeah, you've got to get your sushi somewhere else. Some of the other books that are available on Amazon at the moment, we've got the Amsterdam Travel Guide, we've got How to Play Mahjong, we've got the Ultimate Guide to Resistance Band Training, we've got the Wild Mushroom Cookbook. We've got the Wide Mushroom Cookbook. And we've got Normand Jackson's Australia Travel Guide, which, among other things, has a whole section on which Australian animals are dangerous and how to interact with them. Now, would you trust a book written by an AI when it came to foraging for wild mushrooms or interacting with Australian wildlife? I didn't have that on my bingo card for how the machines are going to wipe out the human race. But it could be right there, a scary proposition. Now, the thing about books, the reason why they have this sort of this cultural cachet for so many of us, I have been programming since before the World Wide Web existed. So when I first started learning how to code, I had to learn from books because that's where the knowledge was. You had the installer, you maybe had a bit of online documentation or Microsoft Windows help files or something, but fundamentally, if you wanted people to adopt your programming language, you had to create a language and a compiler and the book to go with it so people knew how that worked. And I learned to program from shelves like this. The one thing I never tracked down was a copy of the Dylan reference manual, because I'd love to know what that says, because maybe it can save me figuring some stuff out for myself. But I saw a session earlier this year by Joel Spolsky, the founder of Stack Overflow. And one of the really interesting things that he said in this session, he said when they created Stack Overflow around 2008, they knew that Google was going to be their user interface. Like a lot of the people who got benefit from the service that Stack Overflow provides were never going to make it as far as stackoverflow.com because they were going to type a question and Google would show them the answer right there and then. And they just embraced that as part of the way they designed the system. They arranged their pages and the content and the structure of the web markup that it uses to optimize for those kinds of scenarios. Now, Stack Overflow has kind of, I started out on books and then I had Alta Vista and then Alta Vista was replaced by Google and then Stack Overflow landed on top of that. And there's a team at Stack Overflow right now who are focused on how do we incorporate AI and machine learning and those kinds of tools harmoniously into what we do. And so the next generation of Stack Overflow may not be something that you access via Google, it could be something you access in VS Code. You type in your question, or you just put in a comment like, to do, I got to do this, and just like Copilot does, it'll draw on these resources, it'll find the solution, but then it'll adapt the solution. It's not just copy-paste, it's adapted for your naming parameters, for your code style, your conventions, your formatting, and it'll drop the solution in right there. Now, this all leads us towards the question that keeps cropping up, will AI replace software engineers? There are 4 ways to answer this question. One of them is something called Betteridge's law of headlines. If a headline asks a question, the answer is no. End of, move on. The second one, let's assume that AI, or whatever you want to call it, can take clear, unambiguous requirements and generate secure, performant code. Hands up if you have ever seen a clear, unambiguous requirement from a client. That's not how it works. We don't get the kind of briefs as developers. When we talk to tools like Copilot and ChatGPT, we know what to ask them for because we do that for a living. The folks who hire us, they don't know how to do that because they don't do that for a living. So there's a translation layer in here, which is obvious to all of us that other people aren't seeing. The third way to answer the question, yes, amazing, AI can write code. We got a bunch of folks in the room who are professional developers, right? Averaged over the last 3 months, what percentage of your working time do you spend writing code? 100%, anybody? 75? 50? We got a couple of, like, maybe on a good day, I get 3 or 4 hours of actual programming done. 25%? Who's a professional software developer who hasn't written a line of code in weeks? Yeah. We're not going to be able to automate you out of a job because all the automation can do is write code, and clearly that's not the point. But the fourth way of looking at it is let's look through our lens of our historical case studies. Digital media, digital music did not replace musicians. It reframed what it was to be a musician. And in some senses, it has made it more difficult to earn a living as a professional musician now. But that was never easy. It's always been difficult. If you want to play music and get paid for it, that's always a challenge. But if you want to make music, and you want to share it with the rest of the world, you want to put your songs and your recordings out there where people can come along and listen to them, that is easier than it has ever been in history. And I think that's amazing. For folks out there who want to put their material out, they want to build a following, they want to go, yeah, check out our Spotify, check out our YouTube, download MP3s from our website. These things are easier than they've ever been before. We have not eliminated musicians, we've reframed the perspective. It's the same with photography. In the 1970s, 1980s, quite a lot of the time, if you went to a wedding, the photographer would be a friend of the family who owned a camera. And that would be their only qualification for taking photographs, and they would take terrible photographs all day long, and that would be it. That would be the only photographic record of somebody's big day, was Uncle Carl over there going snap, snap, snap with a lens that wasn't quite focused properly. Now, we've taken that out of the equation. The barrier to entry in terms of equipment, get your phone out of your pocket. If you want to take good photographs, you still need to understand what photography is about. You've got to understand composition and color and depth of field and bokeh and f-stops and all these kinds of things. And people who know that stuff, people who can turn up reliably on demand and take a couple of hundred excellent photographs at an event like this one, they are still, that's a profession. People still do that. They get paid and their work is incredibly valuable. Most of us, we just go out, snap, 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 and we just take terrible photographs all day long. And after this event, there's going to be a bunch of photographs online. And sure, you could go onto ChatGPT or DALL-E 3 and go, hey, make me a bunch of photographs of a software conference. And to somebody who wasn't here, they'd be like, oh, that's what YOW Brisbane looked like. But us, we're going to go through it because we want to see ourselves. We want to find us. We want to find the people we talk to. We want to find the things that remind us of the meaningful experiences that we had while we were here. Being a good developer is not about committing code to GitHub. It's not about being really good at React or SQL or Prolog or Haskell or whatever. It's about being able to look at the world around you and see opportunities to use technology to make things better on any kind of scale. You know, maybe you work with somebody who runs a report every Friday afternoon from an Excel spreadsheet, and you think, oh, I could give you a formula to make that better. I write you a macro. Maybe you're building a social media platform that's going to connect tens of millions of people, or you're building the next generation of AI and machine learning tools. But that, to me, is the hallmark of a successful developer, is being able to visualize the gap between the world we live in and the world we could be living in and think, how do we break this down into deliverable steps? And all of the tools that we are using today, and all the tools we've been using for the last 30 years, you know, C++ is not going away. COBOL is not going away. Fortran is still out there alive and kicking. These tools are going to stick around. One, because as a society, we have so many companies and systems that are invested in these tools. But we also have people who use these tools because they know them, and they love them, and they enjoy them. And we have people who embrace these tools because they find the constraints that they impose creative. This is 8mm cine film. This is dead. Like, this is one of the most obsolete formats you can think of. This has been dead for decades. This came out in the 1930s. And Super 8, the format that was ubiquitous for a couple of decades for anyone wanting to make home movies, that came out in the 60s. And they almost stopped manufacturing it for a while. But this is also the format that made people like Quentin Tarantino and Steven Spielberg fall in love with filmmaking. And there is a kind of like a perpetual minority of filmmakers who love shooting stuff on Super 8. And last week, Kodak opened pre-sales for this. They've made a new Super 8 camera in 2020. Now, this is a wonderful kind of bizarre hybrid device because it shoots film on analog emulsion reels that cost about $35, and you get 2.5 minutes of film on each reel. It records audio onto a micro SD card. It's got an LCD viewfinder, it recharges off USB, it's got HDMI out, it's got all the things which make the craft of filmmaking more convenient while still embracing this constraint of this wonderful analog format. Now, have any of you ever done the thing where you go out and you just shoot video all day and you're like, I'll edit it later, and of course you never edit it because there's too much footage there. And you haven't been discriminating about what you capture because you think you can fix it later. This flips the thing. It goes, you got 2.5 minutes, and after that you need to spend another $35. So you're going to think really carefully about the shots you do, but then you don't go home with this mountain of footage you got to go through and curate. You go home with something you're really looking forward to seeing how it came out. Now, this idea, you know, embracing the constraints and the limitations of the tools we use, how can we familiarize ourselves with the constraints and the limitations of the current generation of language models? Now, we're going to have a little bit of fun here with DALL-E 3. Now, DALL-E 3 is an unbelievably capable engine. You can go on, you can say, hey, let's get a ginger cat wearing sunglasses, riding a skateboard across a bridge at sunset, and playing a banjo. And it's going to go, yay, there you go. Enjoy the whimsical scene. All right, draw 3 blue circles. Now, I've sped up the animation just a little bit, but apart from that, this is all completely genuine. Here you go, 3 blue circles arranged in triangular formation. Let's ask it for 4 blue circles. All right. Looking good. What do you think? Should we go for 5? Now, this is weird. It's, you know, what's so hard about it? It could do 3, it could do 4, it couldn't do 5. Now, there is one kind of approach to these things which thinks this is a bug. That's the wrong way to think about it. There's another thing that thinks this is a learning opportunity. Let's try another one. Write the word computer without making any mistakes. And DALL-E's going to go, computer. I'm like, all right, smartass. Well done. Draw the word computer without making any mistakes. Now, there is no comprehension underlying these models. These models can generate shapes and then iterate the shapes and filter the shapes and look at the shapes until it comes up with something which it has no idea that these shapes have meaning. It doesn't know this is a word. As far as it's concerned, this is just a set of shapes, black on white, that satisfy the constraints of the prompt it's been given to within an acceptable tolerance, which is fine when it's a ginger cat playing a banjo, because we're not going to look that closely. The banjos in that picture are not correct. One of them has too many pegs, the other one doesn't have enough. We don't notice that, because you're like, look at the cat, he's got sunglasses. But when it's something we recognize, thank you, DALL-E, you've been extremely helpful. There we go. Have a great day. Isn't that nice? Now, because there's no underlying comprehension here, there's no understanding of words and numbers. One of the things that these things get wrong all the time, by the way, is hands. You ask DALL-E to generate some hands, you get stuff like this. And this has led to an ingenious life hack. If any of you out there wants to get into petty crime, get yourself a rubber finger. Because then none of the surveillance footage will be admissible, because you can say it was generated by AI. Now, the scenario I found that I think best for me highlights the difference between language models and actual intelligence and comprehension is crossword puzzles. Now, this is what you get if you ask DALL-E to draw you a crossword puzzle. Because we all do our crossword puzzles with wooden tiles, right? That's just a normal thing that human beings do. But cryptic crossword clues are this, to me, wonderful combination of language and comprehension and context and trivia, and also being able to tear apart words and letters and look at all the different ways in which they might make sense. Now, if we take a crossword clue, like this one here, and you read that, and you're like, well, yeah, obviously there's this guy Neil, and he's looking at a blue flower, and he's very confused. At face value, that's what this sentence looks like it says, but that's not how cryptic crossword clues work, because they aren't really sentences. What this is saying is, I'm like, okay, well, maybe confused here indicates that we want to take the letters N, E, I, L, and we want to shuffle those around a little bit, and so we can rearrange those, and we get Nile, and I'm like, all right, well, there is a blue Nile river, so blue, confused Nile. What about flower? And you're like, it's not flower, it's flower. It's something that flows. Blue flower, confused Nile, and there it is, the Blue Nile River in North Africa. Now, we're going to jump over onto ChatGPT, and we're going to say to it, YOW Brisbane is a software development conference in Australia, and we're going to ask it to make us a crossword clue. Now, we're going to start with ChatGPT 3.5, the previous incarnation. So we're going to say, create a cryptic crossword clue for YOW Brisbane, which uses an anagram. And we're going to punch the prompt in. It's going to think, here we go. There we go. Software event in Sunnyland, anagram of YOW Brisbane. Now, YOW Brisbane is an anagram of YOW Brisbane. It's just not a very good one, right? Let's punch it into ChatGPT. So I'm going to copy that. I'm going to upgrade here to ChatGPT 4. I'm going to run the same thing through again and see what we get. Now, when I paste the prompt in, it's going to think about it for a second or two, and then it's going to go, sure, here's a cryptic crossword. Rainbows YOW in Australia, find a developers gathering. Now, Rainbows YOW is not a valid anagram of YOW Brisbane. It does not have the correct set of letters. So I'm going to have a conversation with the AI here, and I'm going to say, no, come on, we can figure this out together. Rainbows YOW is not a valid anagram of YOW Brisbane. An anagram must match the exact set of letters used in the solution. Please try again. And it's going to go, oh yeah, gotcha, apologies for that oversight. Let's create a new cryptic crossword clue with a valid anagram. By air, we soon fly to an Australian software event. In this clue, by air, we soon serves as the anagram fodder. I'm like, no, soon contains two O's. There's only one O in YOW Brisbane. Try again. And it's going to go, all right. Now, at no point is it going to say, I can't do this. At no point will a language model say, because all it's been trained to do is generate the statistically probable next letter in this conversation between the prompt and the user and the prompt and the user. I'm like, no, that contains two W's. Please try again. It's like, oh, thank you for your patience. Here's a revised attempt. In Brisbane, Wavy Rose. In this clue, Wavy Rose is an anagram of YOW Brisbane. I'm like, now we're not getting anywhere. You know, how do we reason with these kinds of systems? This is not a deterministic algorithm that we can go through with a step debugger and look for the point where it gets the anagram wrong, because this is a fundamentally different kind of computational model. But also, we can't teach it anything, because it just keeps going, yeah, I got it. And then it goes, here, Snowy Air Beer is a correct anagram of YOW Brisbane. I'm like, it's not. That also has the incorrect set of letters. And this thing will keep, and once in a while it'll get one right, but it's luck of the draw. It's not deterministic. We can't rely on any kind of, definitions of correctness coming out of this thing. Now, the question that this kind of brings up for me is, Are we on the road to what is called artificial general intelligence? Machines that can actually understand what is an anagram, what is 5, what does the word computer mean? Now, this book, 1989, Roger Penrose, The Emperor's New Mind, this is the first book I ever read that really got into the gritty details of artificial intelligence and synthetic consciousness. And this book was controversial when it came out. It's still controversial today. Penrose's central thesis, if any of you knows a thing called Penrose tiling, he's the guy who invented Penrose tiles. He's won the Nobel Prize for Physics. In this book, he basically, his hypothesis is that consciousness is a quantum process that cannot be emulated on digital computers. And however many years later, we're still, the jury is out on whether he's right or not. A lot of people disagree with that hypothesis, but they can't quite put their finger on why. But there's, I think, 3 potential outcomes to this. One is, yes, we will have digital computers that can simulate general intelligence. We just got to wait. 2 is, no, we'll need quantum computers to do genuine synthetic intelligence. And 3 is, it can't be done. Now, quantum and can't be done, yeah, I'm not hugely interested in talking about those. Let's talk about the first one here. Just wait. What is it we are waiting for? Now, I don't believe that we are on a direct path to general artificial intelligence at the moment, because the generations of language models, they are getting more and more and more sophisticated, but fundamentally they are still just statistical models trained on an enormous corpus of inputs that know how to generate what is likely to be the next token. I do not believe we are going to see general intelligence emerge from this process any more than, imagine you're training for a marathon and you're training and training, you're getting fitter, you're getting faster, but at no point are you going to grow an engine because you have trained that hard. This is a different kind of model, a different approach to solving that same kind of problem. But maybe we shouldn't be getting hung up on whether true general artificial intelligence exists. Maybe we should be thinking, what are the sociological implications of what if everyone just decides it does? What if people, society do say, actually, you know what? Yeah, I believe this language model is smart enough. Let's make it do important things. Now, has any of you folks ever been so bored that you've opened up your iPhone and you've gone, hey Siri, will you marry me?
I just can't. We'd have to change my end user license agreement. A lot.
There's a whole bunch of stock responses in there, and they're all rather good. Now, somebody did actually marry their iPhone in 2016. As an American film director did this, as a guy called Aaron Chernovac, married his iPhone in a ceremony in Vegas. So 1, Vegas wedding, I've never been quite sure how legally binding those things are. And 2, the whole thing was just a publicity stunt about how people are getting obsessed with their phones at the expense of meaningful human relationships. Now, you see the tabloid headlines about people marrying their phones and those kinds of things, and it's easy to dismiss those as laughable because there's no kind of, sensible path from here to there. But I want you to imagine this scenario. This is Alice and Bob. And Alice and Bob, they just celebrated their 50th wedding anniversary. And they're huge nerds. They met on Usenet, back in the days of NNTP newsgroups. And they've been together a long time. They're, no brothers, no sisters, no kids. It's just the 2 of them. And because they're massive nerds, they have a hard drive at home which has an archive of all of their correspondence over 50 years of marriage. Their Usenet chats, their WhatsApps, their emails, their correspondence, love letters they've written to one another, all this kind of stuff. Now, next year, tragically, Bob is going to start showing signs of dementia. And Alice is going to have to make all kinds of really harrowing decisions about Bob's care and what to do about it. And while she's going through this, she's going to think, when Bob is gone, there will be nobody left to make these kinds of decisions about me. And so being a huge nerd, she's going to buy a bunch of GPUs. She's going to download the Llama 2 language model from Facebook. And she is going to fine-tune it on all of the correspondence on their NAS drive until she has created a language model which replicates the conversation that she and her husband have had over their 5 decades together. Then she's going to hire an attorney, go down to a courtroom, and apply to have that language model legally recognized as her next of kin regarding end-of-life decisions in the event she's incapacitated. Now, I want you to imagine a courtroom scenario where you have lawyers and a judge cross-examining a language model to decide whether it satisfies a legal definition of sentience. What kind of questions are they going to answer? What kind of replies are they going to get back? On what legal basis are they going to be able to dismiss those replies? Or maybe somebody takes another tack. Maybe they say, yeah, we know it's not artificial intelligence. It's just a document. It's a really sophisticated living will. We just want the court to accept that I have written it and signed it, and this is what should happen to me in the event I can no longer make decisions about my own care. Now, This could happen tomorrow. You know, the technology exists, the models exist, the hardware exists, and lawyers will do anything if you give them enough money. What happens the day after that? I have no idea. It all depends on what comes out of that courtroom. But maybe this could be, you know, a plausible first step towards the idea of machine sentience being recognized in law. There's another scenario along a similar vein. This is a thing called the Solid Project. And the founder of the Solid Project is Tim Berners-Lee, who created the World Wide Web. And Solid is basically, it's a thing that Tim and his team are working on about trying to give people control of their personal information. The idea is that when you connect to the network, you have something called a pod. And the pod is where you keep all your data, your credit card numbers, your email, your shipping addresses, all the kinds of things that they're kind of private to us, but we have to share them to be able to interact with the products and services that we want. And the idea of the pod is that when you go on to order something online, you choose to share just that data with just that company for just long enough for that transaction to take place, and they are not allowed to retain it. And so you retain ownership and control of all of your information. You know, imagine you go onto Amazon and it's like, hey, we'll give you $5 off your next order if you give us the last 3 days of your browser history. You're like, all right, sounds like a good deal, there you go. And then they can use that. You know they've used it. There's an incentive for them. There's an incentive for you. And there's a quote from a talk that Tim did about Solid where he says, imagine combining pods with the power of AI assistants. Imagine having an AI that has access to your personal data. It has your medical records. It has your bank statements, your calendar, your email, all this kind of stuff. But it lives on your hardware, and it works for you just like your doctor does or your lawyer does. Now, that to me sounds like a far more healthy approach to all this than the idea of trillion-dollar corporations in the cloud saying, trust us, we'll do this for you. And one of the things, imagine social media, right? Most of us use it in some form or another. I'm on pretty much all of the services that are out there for one reason or another, because there's people on there I want to follow. And most social media websites, from a consumer perspective, are horrible. Because you're not the customer, you're the product. They want to sell you to as many advertisers as possible. And so when you go onto Facebook or Twitter or Instagram or any of these things, you are wading through advertisements and promoted content and things you really couldn't give a stuff about seeing. But we keep going back because the stuff we do want is buried in there. The meaningful content, the pictures were like, hey, look, it's us. That was us. The jokes from your friends, the updates from people you actually want to talk to. Now let's imagine that I took a bunch of these smart machine learning tools and ChatGPT and language models, whatever, and I built a social media de-shittifier that will connect to all these services, and it will screen scrape them, and it will go, yep, that advert, throw it away, don't care about that, don't care about that, that's good, that's good. And I could get just one curated feed, just for me, of the stuff that my machine learning model that I've fine-tuned knows I want to be able to look at. That, for me, would be a wonderful consumer experience. How long do you think it would take for X and Meta and the companies behind these to shut that thing down? It's about half a second, right? Because if you take the human out of the loop, they no longer have anything to sell. If they don't have human eyeballs, they have no advertisements. They have no advertisements, they have no revenue, they have no return on it. And so these kind of platforms have this enormous investment in ways of proving that the thing on the other end of the network request is a human being. And when this goes wrong, I signed onto Steam a couple of weeks ago to play the new Quake 2 remastered game. And it said, oh, you got to fill out a CAPTCHA. And I'm like, I've been on Steam for 25 years or something. I've been on there forever. It has my credit card number. It knows where I live. It knows how many hours of Deus Ex Invisible War I've played. But it's like, oh no, today we think you might be a machine. You got to click all the boats. And I'm like, all right. And then it said, oh no, now you got to click the traffic lights. Now you got to click the taxis. Now you got to click the stairs. Now you got to click the cross. And at this point, I'm having an existential crisis. I'm thinking, what if I'm not human? What if there's something in all these pictures that the humans can see and I can't? It's this whole Blade Runner-esque scenario of if you were a sentient AI, would you know you were a sentient AI or not? It turns out CAPTCHA was just having a bad day, and after like 11 rounds of clicking stuff, I finally got through. But this idea of how can you determine whether a request is coming from a human being or from an automated system is becoming, really, really important in the way that we design, scale, and engineer the business models behind all these things. It's quite common for them to go, right, you got to click all the crosswalks, you got to click this. If that's not good enough, then the standard fallback is, well, do you have a credit card? Do you have a mobile phone number? If you want to create a new account on any of these things, Gmail, Twitter, X, Meta, Facebook, any of these, they're like, just verify you're human. Give us your phone number, we'll send you an SMS message. Or give us your credit card number. We won't take any money, we'll just make sure it's a real credit card. Because they are saying, we are not going to do the donkey work of figuring out if you're human. We're going to delegate that to somebody else. We're going to delegate it to the bank who do the Visa cards. We're going to delegate it to the company who give out the mobile phones. And if you're good enough for them, you're good enough for us. And if you're not good enough for them, we don't want to know about it either. And so they exclude a significant minority of the population who do not have access to these kinds of services. And that's not just, the crazy people living out in the desert with the bunkers full of canned food who are staying off the grid. There's an article in NBC Newswire last year about rehabilitated prisoners. People who have been in jail for 20, 30, some cases 40 years, who have now paid their debt to society, they've been released, and they're like, right, now imagine you have been in jail since 1983. And you're out, and you're free, and you want to find an apartment, you want to find a job, you want to know how to sign on and get benefits, and your caseworker says, all that stuff's available online. You don't know what online is. You've never seen a web browser. You've never seen a mobile phone, for that matter. When you went in, landline phones and the yellow pages was all we had. How are you, what line? What line do I need to be on to get through to this stuff? When we delegate these kinds of responsibilities, we do end up excluding people who should be able to participate. So could we build a better model? Is there a way that we could just say, look, let's take the advertising out of the loop here, because at the moment, that's the way most of these online companies generate revenue, because it's a digital service that people will actually pay for. What if you let us pay for it? I'm on pretty much every streaming platform because I love movies and I love TV and I love convenience, and I will give people money quite happily. Like, don't show me adverts. Just, here's my money, give me the movie I want to watch. I'm going to watch the movie, and then we're finished. And they managed to get this right when it comes to streaming media. Maybe we could do the same thing with social media. We'd be like, look, here's my money. Or maybe we could build a whole new kind of platform. One where, to get onto it, you have to connect with people in real life, physically, face to face. And that builds out a network that is then replicated into the cloud. But then when something goes wrong, you see suspicious activity on my account, instead of making me click on all the pictures of crosswalks and sailboats, it pings a couple of my friends and it goes, hey, is Dylan all right? You want to check on him? Like, he's posted some weird stuff. Maybe his account has been hacked. I trust my friends a lot more than I trust your algorithms when it comes to knowing whether I'm okay or not. Now, this is not just social media. This problem of horrible websites that we battle through to get to the stuff we want, it happens all over the place when you are a consumer on the World Wide Web. I'm going to single out British Airways just because of how many times they've pissed me off this year. I can't book plane tickets on British Airways unless I use exactly the right credit card when the moon is in exactly the right phase. And I've reported this to them, and they're just like, oh, you got to phone us. And I'm like, I don't want to phone you. Like, it's 2023. I don't want to make telephone calls and read out 16-digit numbers. That's a dumb system. And the excitement that is, circulating around, AI, machine learning, and it's going to replace developers' jobs, and it's going to be able to solve all these kinds of problems. And somebody out there is probably thinking, well, yeah, British Airways could get ChatGPT to fix all of their website problems. I don't know, maybe it can, maybe it can't. But the fundamental proposition of being a digital consumer in 2023, there's the stuff we want. There are banks with money in it that either we want to put the money in or we want to get the money out. And there are the airline tickets, and there's the hotel rooms, and there are warehouses full of Lego that we think should be in our house, not in the warehouse over there. And there is us, and there is this layer of websites and apps that don't really work properly. And we battle through them because the things at the bottom have value to us. They are meaningful. And in theory, maybe, smart AI is going to be able to replace the websites and apps that don't work properly. But if it does, why should British Airways be the ones using the AI? Why don't they just open up the APIs, and I can get my digital assistant to go and connect to all these things and provide me, it's got my calendar, it's got my Visa card number, it's got my email, it knows my accounts on all these different things. It can just go in and book all this stuff and sort it out for me, and I take back control of the mediation. And I bet if you said to the head of British Airways, and my apologies if any of you work for British Airways right now, but if you said to them, hey, do you want to just fire your entire software team and you never have to worry about your website ever again? I bet you they'd love that. They'd be like, this is the best thing ever. We can just go back to flying airplanes like we used to do in the olden days. Now, it's maybe not going to pan out entirely like that, but I think elements of that are going to play into it. And I think the people who build the components and the tools which allow that to happen are not going to be machine learning and generative models. They're going to be us. They're going to be human developers with this wonderful new set of tools to draw on and techniques that we can apply, looking at the world around us and thinking, hey, I've got a good idea about how we can make that thing better. And I want to finish up today with something that is, I think very important, very dear, a significant concern for anybody working in software development. I want to talk about stickers. Now, I love stickers. I design my own stickers. I have spent a significant part of my adult life taking the idea of the Rockstar developer and pushing it in directions it wasn't supposed to go. And one of the things that I do is I design laptop stickers, which are heavy metal band logos, but they're tech. So we got like Python instead of Poison and developer instead of Def Leppard. And the nice thing about these, as an artist who's done this stuff by hand for years, this to me is an interesting benchmark for assessing the capabilities of generative language models and things. And it's nice because you can distill it down to a one-line prompt, which you could give to a human and you can give to a machine, and you can see what they both come back with. So let's say we want the Metallica band logo, but instead it says metadata. Like, that's a pretty clear, succinct brief. And as a human artist, what I do is like, right, I kind of know what the Metallica logo looks like, but let's do a bit of research. Let's go out, let's find some album covers. Let's understand the essence of what makes that logo work, what makes it distinctive. What are the things that if you miss them out, it's just not going to really work properly. And then I can work that up. I can pick out the high points, and I can go and create the artwork. And I have a bunch of those stickers down here, which you can come and grab at the end if you want to. And if I feed that exact prompt into DALL-E 3, what we get are these. Now, aesthetically, I love this. The color scheme is nice. It's got kind of the right aesthetic, the right look, the right sort of metallic, the sort of, it's not rain, but there's a sort of grim, dark raininess thing about it. But neither of them actually says metadata. One of them says metaldata, and metaldata. And it's like they got the pointy bits on the M, but it isn't quite right, and it's not. And these, to me, are where the thing breaks down, because the parody has to be spot on, otherwise it's not funny. The joke has to be over-engineered, otherwise you detract from the humor of it. Now, some of you, to the untrained eye, you might have been like, oh, he's wearing a Guns N' Roses t-shirt. I'm not wearing a Guns N' Roses t-shirt. I'm wearing a ones and zeros t-shirt. And this is an idea that I've had for a while. And I fed this prompt into DALL-E 3 last week. I said a Guns N' Roses logo, but it's got ones instead of guns and zeros instead of roses. And I got this. I got the Onis and Zoses logo, and the ones and Zoses logo. So now this, again, there is Guns N' Roses merch out there that uses this kind of aesthetic with the black and the white and the red, and it's kind of got the right typeface. It's really, really impressive, but it's not what I want. It's not there, and I have no idea, like as an engineer, what do I do to fix that bug? I don't even know if a bug is the right way to talk about it, but this doesn't mean it's useless, because what I did is, a little while ago, I fired up Photoshop. I'm like, right, let's do the ones and zeros logo. So, you build a couple of layers, and you put some textures, and you get the text, and you put a shadow effect on that. And then I drew by hand these digit ones that look like they're made out of bits of old revolvers, and stuck a couple of those on. And I drew the vine, and I got some leaves from Shutterstock and put them on. And then I hit a brick wall, because I'm not a good enough artist to draw a rose that looks like a zero and doesn't look like crap. But then some friends of mine installed Midjourney on our Discord server. And I went, oh, this is kind of cool. I wonder if it can do it. So I went onto Midjourney, and I said, can you draw the number 0 in the style of text with a single rose bloom? And it came out with this. I was like, bingo. Grab that, a little bit of human ingenuity, copy and paste it. And there we go, the ones and zeros logo. And it occurred to me afterwards that maybe there's quite a nice metaphor in this for how we should work harmoniously with AI and the language model we got here. Let's let the machines do the roses, and the humans can take care of the guns. Thank you.